Alright, good morning, Geometry Honor students. So Mr. Chen's again. So this one, today I would like to talk about sections 9.2. So the continuations of chapter 9, so special right triangles. So objectives for the lesson today, so make sure that we know how to use the ratios of the side lengths of the special right triangles. So one is considered 30, 60, 90, and the other one is 45, 45, 90 degree triangles. So utilize those two special right triangle, we can find out the missing segments, the side length, and also sometimes the missing angle. So for the 30, 60, 90 degree right triangle, so we do have the ratios as 1x, root 3x, 2x. So here's the diagram for the right triangles. So 1x, root 3x, 2x. As you can see that the smallest angle is corresponding to the smallest ratio, and the medium's angle is corresponding to the medium ratio, and the largest angle, which is 90 degrees, and it's corresponding to the largest ratio. Okay, so 45, 45, 90 degree right triangles. So another name for that, it's called an isosceles right triangle. So isosceles right triangles, so the shortest leg, so we got x and x, and then the longest leg is root 2x. In order to prove that, we can always put it back to the Pythagorean theorem. So 1 squared plus root 3 squared equals 2 squared. Get a 1 here as well. 1 squared plus 1 squared equals root 2 quantity squared. Okay, so now let's find out some of the examples right here. Find the missing lengths of the special right triangles. So the one that we have for this one is 30, 60, 90. So 30, the corresponding segment here, it's 1x. We don't know what that is. So and the medium side right here, the one corresponding to the 60 degree, it's y. So how do we solve for x and y? So one thing that we notice, the longest leg, the hypotenuse, which is given already, it's 14. So in order to find out the shortest leg, so using the ratio, so the longest legs ratio, which is what, 2x. So 2x equals 14. So solve for x, so we do have 7. So the shortest leg, which is 7. And then to find out what y is, so y is just the ratios of root 3 times x. So root 3 times 2, root 3 times 7, excuse me, so which is what, 7 root 3. Okay, so utilize that, the special ratios, to set up the segments. So once we get the shortest leg, we can get the other segments as well. And this one, 30, 60, 90, so the shortest leg, which is 7 over 3, so that's x. In order to get that, the rest of the segments, y, and let's say this one is z. So y would be considered root 3 times x. So root 3 times 7 over 3. So we end up with an irrational number, so 7 root 3 over 3. To get z, so z would be 2 times the shortest leg. So z equals 2 times 7 over 3. So it's 14 over 3. And then for this one here, we want to get x and x. Okay, so just get one of those. So this one, 90 degree. The other one doesn't show here. Well, it shows that's a corresponding congruent segment. So that means this two angle got to be 45 and 45 degrees. So using the ratio 45, 45, 90 degree triangle. So we got 1x, 1x, and root 2x. To get the value of x, so we said that root 2x equals 38. So solve for x divided by root 2 both sides. And normally we don't allow to leave the radical in the denominator, so we want to rationalize it, multiply by root 2 top and the bottom. So what we found here, x equals 38 root 2 over 2. And don't forget about that reducing. So 38 over 2, which is what, 19. So 19 times root 2. So using the special ratios of the special right triangles. Okay, so now what about something that's getting a little bit more in depth? So given that angle HGD, okay, so HGD, so this one is 30 degrees, so let's just label that. And then GC is 2. Let's just say that's 2 units. So find the value of x, y, z, the segment. So it looks like this one is the inscribed square from another square. So using the properties of a square, so they're all considered right angles, so all four sides are equal. Okay, so all four sides are equal. So let's get that the one of the segment here. So this one is 2. So what happened with the corresponding angle? So using that the linear pair or supplementary angles. So this one is 30, this one is 90. So that means angle FGC, then that'll be considered 180 minus 90 minus 30, then that'll be 60 degrees. So let's just take that angle out. Well, the entire triangle, not just the angle. So let's take out that triangle FGC. So we just want to zoom it in, or we probably want to just redraw that. So we got what? 30, 60, 90. So the one that we found here, so this one is 60. This one up here, which is 30. And then the one here, 90 degree. So again, using that the special right triangles ratios. So right now the shortest leg is 2. In order to find out the hypotenuse here, so that would be considered 2 times x for FG. So that means FG will be considered 2 times 2. Okay, so that would be 4. Okay, so this segment here, so it's 4, 4, 4, and 4. Using that the properties of the square, all four sides are equal. And also at the same time, we can find out that y right there. Okay, so this one is 4, this one also showing that if this one is 30, so that means the other segment, the other angle here, it's also 30. So 30, 60. So another 30, 60, 90 degree triangles. So it's pretty much the same triangle that we drew here. So if this one is 60, so it's corresponding to y here. And that means y will be considered root 3 times x. So root 3 times 2. So it's 2 root 3. And then to get z, okay, so z, which is this segment here. So if you just compare that, looks like this one. Try to prove that by using side, 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 or side angle side. You'll see that z is the same as GC. So z is the same as GC, which is 2. Okay, so this one is one of the particular problem using that the special right triangle, and also using that the congruent triangle CPCTC, so we can get all the rest of the line segments for the missing part of the square. Alright, so that's it. So thank you for watching the video today. So any questions that you have, so you're more than welcome to put into the YouTube comment bar. So I'm more than happy to reply that. Alright, so please subscribe to the channel so there are more valuable lessons coming up for geometry. So I'll see you guys next time. Take care.